So you need to understand it as a workforce enabler. It is meant to help bring a lot of data and tell a story in a concise moment. Right now, it's actually still very challenging with LLM technology today to run an entire factory unless you distill it down. It's like every 6 to 8 months, there's a radical transformation when they release a new system and its capability and software development or interfacing with other systems.
Welcome back to Talent Hunters, where we explore insights and trends shaping the global recruiting and staffing industry. Want to build talented teams that drive your company toward big goals and big growth? Then this podcast is for you. And now, let's join the conversation with today's episode of Talent Hunters, brought to you by HireQuest. Connect with us at hirequest.com.
Ladies and gentlemen, my name is Vince Holt, and I'm the host of Talent Hunters. Today, we have Richard Tabassi, the director of Gen AI and Smart Factory at Blue Origin, located in Tacoma, Washington. A passionate, forward-thinking leader who thrives on building transformative, data-driven strategies. Welcome, Richard.
Thank you, Vince. Appreciate being here.
Well, I'm excited about this because, first of all, AI is changing the world faster than most of us can think. And so what I'd like to understand is, could you walk us through this professional evolution and how your background prepared you for your current job responsibilities?
I can do my best. I think I've had an interesting journey to getting here. I've done a lot of different roles, starting in getting my PhD in molecular imaging. So my background is in imaging physics from the University of Texas Health Science Center. And what that means is X-rays, MRIs, CT scans, etc. And I had the pleasure of joining a company early in my career that actually manufactured these systems. I thought I was going to work on cancer biomarkers, and instead I ended up working on the machines themselves. And during the course of that, because it's a small company and we were an OEM supplier to GE, I just fell in love with manufacturing. I learned to write work instructions. I learned about the quality management system, all the different ISO requirements, harmonization codes to conduct business, everything. And that just sort of set me on a lifelong journey, loving manufacturing. But at my core, I'm still a physicist. I apply that kind of breaking down complex problems. And at one of my last jobs in medical, we did AI on a data set, and it just blew things through the roof. And I was like, what is this? What is machine learning? What is this data set? And that was at Sino, and we had run through our classifications, and they showed that our device was very viable from this. And it just got me really intrigued. I started studying that quite a bit. And then I pivoted and managed to land at Amazon. And that's where I really got to spread my wings into the big data in every form and fashion, because everything Amazon does is big. And I got to do HR for HR, algorithms, hiring strategies. It's funny, I never thought a physicist would work in HR. And that was where I landed, was high volume hiring. And I got to onboard millions of people into jobs during when Amazon started taking over the fulfillment center hiring, and that transformed into getting to work on machine learning forecasting, machine learning classification problems, helping people get jobs. And then eventually I ended up being a product manager for AI, and then joining Blue Origin, where we really didn't have much to start with, but I've gotten to build that ecosystem with a great group of people.
So, in your experience, because you're heavily into the manufacturing world, please define to people like myself, what is a smart factory?
So I'd say it's part of a strategy to try to manufacture things more dynamically and more efficiently. So right now, most production lines are pretty static. You do a lot of CapEx and you lay out a production line, right? You have a conveyor system of some sort, maybe, or some sort of carrying mechanism. There may be some amount of automation. Automotive is very automation high, but a lot of industries aren't. Aerospace tends to be still very hands-on, especially for assembly and things. And what we see is smart factories, the ability to be much more dynamic with data. So all of your instrumentation, all your machines, your floor, your cameras are contributing to the story of what you're trying to make. And you bring that together with now ML and AI, and you're able to tell that story better and faster and react quicker. So before, if you had, a line outage, it might take a hot minute for that information to come up. people to make choices to reroute, etc. With a good smart factory, all of that information is proactively being taken care of. You have your data feeds, you have something like a unified namespace type broker that's being changed with the states of your production line, with the inputs that you're seeing, with quality information. It just comes together, tells that story, and you're able to say, you know what, we need to shift production, or we need to cut production by 10% today, or we need to accelerate production by 20-30% today. And companies like Amazon are very good at that, doing that at the supply chain level, but it tends to be hard for people to do that at the manufacturing level. There's so much pre-set up and everything to do this. And so Smart Factory is a bunch of software and a philosophy to complement pretty much any of your major manufacturing belief systems. So if you're a big lean practitioner, it helps you do lean faster, better, cheaper, in my experience and opinion.
So with AI, kind of the heart, the pulse of smart factories, how is this impacting the evolution or the need for skilled human labor?
So I think you need even more skilled people, to be honest with you. You need people who can work with these systems and dynamically change with the choices, the systems, or the people that are making choices from that data with the system. So you need to understand it as a workforce enabler. It is meant to help bring a lot of data and tell a story in a concise moment, to where the system itself is given some autonomy to make choices about production routings, different capabilities coming along, future predictions on forecasting. Or conversely, you need people who understand the story, and be able to represent that to the floor. So if you have a dynamic assembly environment, if you've seen videos of the Ford F-150 Lightning being built, right? They had the chassis on AGVs floating around to these different work centers. And that's really probably where the future of manufacturing is going, for these kind of like lower volume, high complexity assembly builds, is having people who can dynamically react to where the vehicle needs to go, or a quality event happens and they can go rush towards it. And so what you see is people moving towards like call board systems. You see people on call ready to go out there. Whereas before, it's like, here's your work center. This is where you are 24, your 12-hour shift, and this is all you do within this. It's becoming much more dynamic to actually achieve the rates and to embrace the different kinds of configurations of manufacturing we all do.
Old school person, okay? Everything had the human involvement of literally doing the work.
Yep.
With AI, with the smart factories, what slaps me in the face is it's all manufacturing is going into a process. I go back to the human element of it. Yes, it takes the human person skills to program. It takes the human to be able to set things up. But where this is happening so fast. I mean, AI is hit in the last 24 months. It's controlling everything.
Yep.
And I mean, these kids that are getting out of school, these people that are involved in manufacturing and so forth, how are they to get up to speed or get ahead of the game in regards to AI and smart factories?
Yeah. So that's a great question, Vince. So we're doing a lot of interviewing, and I've gotten to talk to a number of people that have kids that are friends of ours. And honestly, some of them are the best users of Gen AI. Like, they're basically growing up with it. They're using it to do all kinds of things I never thought I would ever be able to do. And so we have less of a learning curve there, I think. I think trying to show the value in how to apply it to manufacturing and connect the digital world and the physical world into a solution is coming up very quickly. And you can already start to see a lot of college projects that are taking in generative AI, LLM technology, VLM technology, and merging that. I think what they need for a smart factory perspective is to kind of come up out of the weeds, look at that 50,000 foot level to see the whole story to make the vehicle or the assembly or the parts, right? A lot of times people are good at hyper focusing, but like putting the system together, I think, is where we have some of those challenges to see what those inputs are. Right now, it's actually still very challenging with LLM technology today to run an entire factory unless you distill it down. There's just too much information. The limitations of LLMs and their ability to understand context is very high. You have to provide a lot of additional language and information. It's not just you can stream in a bunch of numbers and then you get a bunch of numbers out. It doesn't quite work that way. So I think helping, bringing people to the factory. We support at Blue Origin. We have the Future Club of the Future. We bring people over, college graduates, et cetera, to come tour and see it. And we walk through and we explain how we're using robotics and connecting that with AI and ML and telling that story of how you build each one of these work centers. And each one of these work centers tells a different story and executes a different component. And we collect those stories and we can tell where the rocket is being made, or in the process, or the engine, et cetera. And I think just bringing people in and showing them and showing how we're connecting it through software and how much of this is an interconnected ecosystem helps bridge some of that thinking.
This is all fascinating to me because I'm a hands-on, see it work type of a person.
Yeah.
Don't play.
You're talking about bringing people in, showing them around, showing them what's going on. I understand what you're saying, that, we're in the infancy stage of all this. How does Blue Origin approach the recruitment and retention of talent in such a competitive landscape where this has got to be bringing up new challenges that a lot of people aren't even aware of yet?
I think we have the same strategy as most people. Preferred schools, looking for certain key elements of their education. We partner with different universities. They ask us for different curriculum. Like, we have a very close partnership that's very public with the University of Washington. My boss, myself, we've gone up there. There's a Dave Limp recently visited earlier this year. And we help with their, the curriculum. That was one of the things I put in my article on my LinkedIn was, forming this partnerships of like, what do you want to see out of this? And one of the conversations we had is like, oh, we only teach, the graduates robotic programming and things like that. I'm like, believe it or not, most of the stuff we have to do is with CNC. They're like, oh, nobody does CNC, education and training anymore like that. And I was like, that's a huge gap. That's a massive gap. We run massive machine shops to make high precision, aerospace parts. Whereas robotics, the biggest robots can't move our biggest components. So we rely on cranes and other kinds of positioning systems. So they were really surprised to hear that. And they're like, we may have to adjust our curriculum to help do this and build some future thinking into that area.
What's your advice? And I'm going to take this into two parts. The first one is, what's your advice? You're dealing with the Gen AI, you're dealing with the smart factory. What's your advice to the workers that want to get into this? What approach should the person that isn't up to speed with everything today, where would you tell them to start their education to get ahead of the game?
My personal opinion is, because it's becoming so ubiquitous, there are some free portals that let you utilize these kinds of technologies. And there is now a pretty healthy amount of information on the internet from Google, from Meta, from from Amazon, explaining how to do prompt engineering and how to think about it and how to structure your queries to get the maximum out of these systems. And I think like I'm a project-based learner. I was more of an experimentalist than a theorist. Is probably why I fit in well with what I'm doing. And I think picking some projects and asking pose your questions like the system's a teacher and see how it would tell you how to break down the project and try to work your way through it. Like I use LLMs as a friend, as a companion, as somebody, as a mentor. And I think putting that persona, which you can do, and getting that information back and trying to work through it the way it's structured it, but also challenging the technology as you're doing it. So there's a company called Grok. They serve up open source models. It's one of the faster They're a hardware company that serves us up to show how fast their systems are. Most of their interfaces are free to go check out and use. They just have a portal up. That's a great way. It costs you no money. If you want to use some more of the enterprise grade LLMs, like I know Claude via Anthropic and OpenAI, they have some amount of like limited uses for people. Take the plunge. Try it. Read what Google's putting out. Read what OpenAI is putting out on how to do the prompt engineering, how you communicate with it. Because the better you can communicate with that, you'll find yourself actually communicating better with maybe some of your peers, with your other teams. Some of the systems we built taught us to communicate better. Some of the software that we built to take transcripts, for instance, taught us like, we talk very vaguely about what we're trying to do. And as we try to get more specific, because effectively the LLM has no context about what we're talking about. So when we're like, that team over there is going to do that stuff and we're going to address that, it didn't know what we were talking about when we did a summary. When we started being very specific about, hey, we're going to work on this feature being, maybe a widget or a button, and we got into the weeds, it did great summaries. It helped us communicate better. So I think you learn a lot just in going through immersion, picking a project, setting relatively low bar, but then starting to ramp up. You can ramp very quickly. It is truly a workforce multiplier, and almost every company that I've seen in aerospace has released some version internally of a kind of chat GPT like system to help employees, usually around documents and referencing and pulling up the company standards or breaks or policies and things like that to decrease search time. I mean, that's probably like the best way, and where the direct applicability comes in.
So let me flip this a little bit, because I think there is a challenge also with the decision makers. Now, you've worked in HR, you've worked on onboarding and so forth. And I believe that there is a challenge maybe with the decision makers and the actual hiring managers, not human resources, in not necessarily being ahead of the game when they're trying to onboard. What's your advice to them in coaching them to take the same thing that we want the employees to do?
Sure. That has been it's hit or miss a little bit in that space. I'll be honest with you, Vince. You get, and it's like everything that we've seen. The people who are very progressive and see the potential, they look and try to explain and get people onboarded for that potential. What I think is interesting about Gen AI and the release of LLMs and the federation of this much information and capability is you're starting to see a split. It used to be like, oh, here's your standard kind of Gaussian normal distribution, and we all fall within it. I'm starting to see more of like a bimodal split. People who really heavily use LLMs in all of their workflows, and from communication, email, automation, parts of their job, etc. And they're starting to really stand out and separate into two different groups. And I think it becomes apparent when you start working with people which group you need to work with to create those change management habits to get the people and the candidates you want in. I don't know if that totally got to where you're looking for, but I think that's like, you need those key champions. You need to reinforce that good behavior. And it helps having really profound leaders that come from technology that embrace this and are willing to accept the risks of using it as a component of doing business and where the future is going.
Blue Origins is growing so fast. I mean, you take Amazon, and Amazon took off like a rocket ship. Play on words. Blue Origins is taking off so quickly, and it's spearheading, I would call, the smart factories. What do you believe, if you look out 3 to 5 years, because this is going so fast, it used to be 5 to 10. 3 to 5 might be a little bit far-fetched. It might be 1 to 3. When you look out 3 to 5 years, what do you believe the evolution of Gen AI and smart factories will evolve to?
It's a really good question. I I don't even necessarily know sometimes what the next release of some of these commercial products are, because it's just been such a leapfrogging. It's like every 6 to 8 months, there's a radical transformation when they release a new system and its capability and software development or interfacing with other systems. And ultimately, the big jump is from the digital to the physical, like actively driving the robots in real time, things like that, making decisions on images upon multimodality in real time. We're a little far out from that. Part of it's a computing problem. Part of it's, we're just really starting to scratch the technology that was unlocked by doing multi-headed attention models and everything, getting that data together. My honest opinion is that you look at what Google recently did with AlphaEvolve, and they just released a paper. And if it really backs up, that's starting to start chipping away at what we call AGI, right? Artificial general intelligence, which is like the ability to start kind of thinking and acting really on its own. Right now, it's a very clever model that is working on just inputs and outputs. It's people like to say it's escaping or sentient. It's not. It's not how it works. But the system that they're purporting that they've built can actually evolve new algorithms, take existing data and apply net new thinking and capabilities to it, etc. And I think that's where it's going, is ultimately we will get to that point where we can, quote unquote, stream in data, a multitude of data, non-destructive testing data, images from the production line, human and-on pushes for the production lines. And all of that will feed into rapid choice making and rapid execution, where our systems and our infrastructure can make choices faster and more logically better. I mean, I would love it to just see it in traffic lights, right? Like being able to use the cameras, nobody's there. Why is the light red? Like, why shouldn't it just immediately flip to green? Things like that will hopefully start going away from old algorithms and PLC programming and, having to go tune it with a person going out there, and ultimately transform into these kinds of systems and networks able to truly take in all of the different visual inputs and transforming that into beneficial outputs to the rest of us to accelerate everything around us in the world.
I have to ask you, Richard, because you are so passionate about this. You're actually inspiring in what you talk about, because you live it, you breathe it. What have you learned since you've transitioned into this? What have you learned that just becomes part of your DNA that keeps that passion driven?
There's nothing like watching our rockets launch. I'll be honest, like knowing that our teams and the products that we're building, the robotic work cells, to the Gen AI enablement, it truly is a thing for me. When I was a young physicist just trying to get my undergrad done, I always dreamed of going into building engines, jet engines, rocket engines. And at the time, it was very much like, this is Rocket Jet Aerodyne, this is NASA, and that's it. Those are your choices. And now with Blue Origin, SpaceX, Astra, Rocket Lab, all these different companies, right? And having these capabilities where we're building them massively cheaper, faster, more efficient. Like, I think people underestimate, people like, oh, why don't you just do like what you did in the 1960s? Why don't you just copy the F1 engine? F1 engine wasn't very efficient. We're able to get that kind of power now out of an engine that's like a fraction of the size. Realistically, that's what just drives me, is that at one point it took a non-trivial amount of the GDP of the entire United States to build that space program. And we were the beneficiaries of the materials, everything that were discovered through that. But now we can build a rocket for hundreds of millions of dollars versus billions of dollars or tens of billions of dollars. And in a few years versus decades of development. I think that's what I love. Like we're enabling that, and we're trying to iterate that even faster with a lot of great partners.
There's no doubt that there's going to be some kids, some very aggressive 20-year-olds that might view this. With your passion, with your satisfaction of where you are in your career today, what advice do you give to them?
Never stop learning. People, I think a lot of people underestimate what it takes to be in this space. And if you talk to anybody in data science, applied sciences at these companies, you are constantly reading publications. You're constantly looking at the state of the art, and you're sitting there and extrapolating it to the problem sets that you have. You're trying to relate your business problems to what you're seeing as the state of the art, because the state of the art is getting matured, like especially in the AI space. The state of the art quickly is ahead of where the paper was, right? And so you got to keep learning. I spend probably 5 or 6 hours after work every single day doing research on what the newest techniques are, how people are evaluating LLMs, what the next training kind of strategy is, right? Beyond just guessing the next tokens with the way we're doing it today. How do we structure the prompts and the inputs? Who's built like the best connectors or the next SDK from Google or whatever that helps you build agents faster? Are agents going to stick around, or is it just going to become like this one thinking system, right? That's where I think a lot of people, even in your just general career, it's a lifelong learning lesson.
I love that. I love that. Richard, I want to thank you for taking the time today. I mean, you broke this down to something I can understand. And you're just an inspiration. You really are. I thank you so very much for taking the time.
I appreciate being invited today, Vince. Thank you for that. That was very kind.